All right, let's look at lesson 5 in unit 5, scaling and unscaling. The image shows the Transamerica building in San Francisco. It's shaped like a pyramid. It's way down here. It's pretty cool, isn't it? Shaped like a pyramid. What are we doing with it? So many papers. The bottom floor of the building is a rectangle measuring approximately 53 meters by 44 meters. The top floor of the building is a dilation of the base by a scale factor of 0.32. Ignoring the triangular wings on the sides, what is the area of the top floor? Explain or show your reasoning. So we're ignoring these, but we go from the bottom up to the top. Okay, it's a scale factor of, they said, 0.32. All right, so I can take each side and scale it down. And that gives me, nope. And you can work along with me. There's no need to just watch me doing all the work. Take notes, write things down. So that's my new length and width of the top floor. Now I can multiply those together. And I get 238.7968, very small. Or that's a lot of decimal points afterwards. All right, we can actually round that. 230, we'll just say 9 meters squared. That's our new area. Now what if we wanted to calculate it in a different way? I see that my scale factor is 0.32, and we talked about it in the last lesson. I can do my area, not 40, 44. Times my scale factor squared. So the area of the bottom floor is 2,332 meters squared. And if I multiply that by my scale factor squared, I should get the same number. 0.32 squared, I get 238.7968, which is about 239 meters squared. So two different ways to calculate that area, okay? We want to make sure that we're using our scale factor squared. All right, a triangle has an area of 100 square inches, and it's dilated by a factor of 0.25. Mai says the dilated triangle's area is 25 square inches. Lynn says the dilated triangle's area is 6.25 square inches. For each student, decide whether you agree with their statement. If you agree, explain why. If you disagree, explain why the student may have done to arrive at their answer. So if the area is 100 square inches and we're dilating by a factor of 0.25, I actually want to square that. And that gives me an area of 6.25 squared inches. So it looks like Lynn is correct. What did Mai do wrong? Okay, I think Mai just took her original area and multiplied it by the scale factor without squaring it. And she got an area of 25 inches squared, okay, which is not correct. This is correct. All right. Now, let's calculate the area of the image of the original triangle dilated by each of these scale factors. If we have the original and we have a scale factor of 9, it's bigger, right? Our answer is going to be 8,100 inches squared. How about 3/4? Again, our scale factor always has to be squared. Easy peasy, okay? Graphing areas and scale factors. An artist painted a 1-foot square painting. So 1-foot square, 1 by 1, 1 foot squared is the area. Now she wants to create more paintings of different sizes that are all scaled copies of her original painting. The paint she uses is expensive, so she wants to know the sizes she can create using different amounts of paint. Suppose the artist has enough paint to cover 9 square feet. If she uses all her paint, by what scale factor can she dilate her original painting? Well, if we have enough paint to cover 9 square feet, it would be the original area times something squared. Okay, well, our original area is 1, therefore we can dilate this by a factor of 3 to use 9 square feet of paint. All right, so that would be a scale factor of 3, because if we square that, we get 9. All right, complete the table that shows the relationship between the dilated area and scale factor. Dilated area, scale factor. Round values to the nearest tenth if needed. So here, this is like an example of our dilated area and our scale factor. To get to it, we took the square root, or we found what times what equals the area. Our scale factor would be 0, 1. The scale factor would be 2. Because if our dilated area is 4, it's our original area times our dilation squared equals 4. Okay, that's our scale factor. Our original area times our scale factor squared equals 9. Well, the only thing that fits into that blank is 3. Our original area times our scale factor squared equals 16. Okay? On graph paper, plot the points from the table and connect them with a smooth curve. 1 second. We're going to do this. All right, I plotted those points, which you see right here. I did not connect them with a smooth curve yet, but what does it look like? Okay, it's a parabola. And I can say, I think I use a semicolon, x is greater than or equal to 0. Maybe not. Oh, I think I use brackets. There we go. So I just want the positives. Okay, it's a squared function. Pretty cool. Check. Use your graph to estimate the scale factor the artist could use if she had enough paint to cover 12 square feet. Okay, so 12 square feet is right about here. About 3.4. I can actually do a y equals 12 here and find where they cross. Our scale factor would have to be 3.464 because 1 times 3.464 squared equals 12. Yep, 11.9999296. Okay, so that would be our scale factor. Suppose the painter has enough paint to cover 1 square foot, but she buys enough paint to cover an additional 2 square feet. How does this change the scale factor she can use? She has enough paint to cover 1 square foot. She buys enough paint to cover an additional 2 square feet. So that's 3 square feet total. Okay? The scale factor would have to be the square root of 3. I don't know what that has to do with anything though. Let me look. Before we get to that, I wanted to show you another representation of our graph. If you look at these points over here, I just flipped them, the x and the y. That means that our input, which is the x, is the area, and the y is our scale factor. Okay, so this right here gives us a function that is actually a square root function, not a squared function. And it actually makes a little bit better sense for the lesson that we're going through. It was hard because when they presented right here, I always do x, y. Oh, but that's what I should have done. Yeah, where this is my x value and that's my y value. When I originally plugged them in, I plugged them in backwards. But I'm all about transparency here, so you'll see the mistake and how we fixed it. So this is our input, the dilated area in square feet, and we get our scale factor, which is the square root. Okay, dilated area in square feet and our scale factor, and that gives us a squared function. Now, when we wanted to find the scale factor, I can still go that way, and I get a scale factor of 3.464. We get all the same information, it just looks a little bit different. Okay, now let's go back here. What were we doing? Number 5. So suppose the painter, all right. So for that number 5, our scale factor would be 1.732, which is actually the square root of 3. Okay, same thing. And what was our next question? Suppose the painter had enough paint to cover 14 square feet, and she buys enough paint to cover an additional 2 square feet. How does this change her scale factor? So she has enough for 14, she buys an additional 2, and that's 16. So the scale factor is going to be 4. All right, we've already done that one. And we're not doing the cool down. Okay? All right. Yeah, that's it.